Today we are starting the third chapter, that is current electricity. In the first two chapters, that means chapter 1 and chapter 2, we were discussing the static electricity which cannot flow from one point to another point. But now the second type of electricity, now we are talking about current electricity. Current electricity is that particular electricity which can flow from one point to another point. In this chapter, starting from the first term, that is electric current, which is denoted by I. So for defining electric current, the flow of charge in a definite direction constitutes the electric current, and the time rate of flow of charge through any cross section of a conductor is the measure of electric current. Therefore, electric current is equal to charge upon time. That means I is equal to Q by T. The unit of the charge Q is coulomb and time is second, but electric current is a fundamental quantity, therefore its fundamental unit is ampere. The dimensional formula for the electric current is m to the power 0, L to the power 0, T to the power 0, A to the power 1. Here A is ampere. Electric current is a scalar quantity. The second term in this chapter is the current density, which is denoted by J, and the meaning of the current density is current density at a point in a conductor is defined as the amount of current flowing per unit area of that conductor around that point, provided the area held in a direction normal to the current. Therefore, current density is equal to electric current upon area, and therefore J is equal to I upon A. I is electric current, A is area. The unit of I is ampere and that of area is meter square. Therefore, the unit of current density is ampere per meter square. The dimensional formula for J, that is current density, is equal to A to the power 1, L to the power 2. Therefore, it is A to the power 1, L to the power minus 2. Current density is a vector quantity. After electric current and current density, the next one is the drift velocity. And for that, the drift velocity is defined as the average velocity with which the free electrons get drifted towards the positive end of the conductor under the influence of an external electric field applied. Then the next term is known as electromotive force. In short, we can call it EMF. The EMF of a cell is defined as the maximum potential difference between the two electrodes of the cell when no current is drawn from the cell. The next one is mobility, which is denoted by mu, and mobility of charge carrier is defined as the magnitude of drift velocity of charge per unit electric field applied. Therefore, mu will be equal to drift velocity upon electric field. Therefore, mu is equal to drift velocity, that is denoted by Vd, and electric field, which is denoted by E. The unit of the drift velocity is meter per second, and that of electric field is Newton per coulomb. Therefore, the unit of mobility is meter into coulomb upon second into Newton. Then we have to classify the material, and they are classified in three different categories. The first one is conductors, and for conductor, those materials whose resistance is very low are called conductor. For example, copper, silver. The second one is insulator. Those materials whose resistance is very high are called insulator. For example, rubber, plastic. The third one is semiconductor, and for that, those materials whose resistance is more than conductor but less than insulator are called semiconductor. For example, germanium, silicon.